Hi, this will be a brief video showing you how to run the tomography inside of Flatirons refraction statics software. At this point, I'll assume you have picks. As you can see, I have picks pretty much through all my offsets on all my traces. And if I click around the survey, you can see that I'm pretty consistently picked here. The program doesn't require perfect picks. It doesn't even require picks on all your offsets. This particular survey has 1,000 shots, about 500,000 traces, and it's picked pretty well. Before I go into the tomography, however, let me show you how to get some information about what you're going to need when we get into the tomography. The program's going to need a range of velocities, a rough range of velocities from the starting to the ending velocities, or your shallow to your depth or your deeper velocities. And the way I get those is under delay time here, under branch assignment. I will click, like for example here, near zero offset, and I'll apply linear move out. And you can just drag your mouse and say there's the initial velocity, which is, you can see it's about, in this case here, it's about 6,100. Let me look at some other places. 6,100 there. This one here may be a little slower. Let me just go like this. So I'm just dragging these velocities, not for the sake of branch assignment, just to get some idea of the velocity range that I want to see in my inner offsets here. So 5,700 there. So that's good enough. So I have 5,700. So I'm going to start off at 5,500 as my initial velocity, or my shallow velocity, and then my deeper velocity. This refractor over here is about 6,800. So I'll use 7,000. So let's say we'll use a range of 5,500 to 7,000. So I'm going to cancel this, and we'll go into tomography. And we will going to construct a new model, and I'll name it here, and I'll call this demo 3D B. And the program allows for a different X and Y node spacing than vertical. So I'm going to use 150 for my surface, 150 feet for my surface X and Y node spacing, and I'll do 50 depth steps, 15-foot depth steps, and I'll use 400 for my maximum depth. That's fine. And then the velocity here is where we put the 5,500, and then here's where we put our 7,000. Now if the program finds velocities outside of this range, that's fine. This just gives it some ballpark to get it going. This program does handle marine type surveys, but this obviously isn't marine, this is land. And so I'm going to create a new model. So the program creates a new model, and by this we mean an initial model. So if I go to profile over here, and then I click and drag this, what I have is, here's my surface topography, and I'm hanging that velocity, that initial velocity. Over here you can see, here's my velocity range. I guess I specified 5,000 to 7,000. I meant to do 5,500. But anyway, so there's my initial model. Now I'm going to update it, and all these parameters happen to be okay, 200 to 6,000. I'll just do I'm just going to do 6 iterations, and I'll let it, I'll do 4 threads. This program will handle 8, so I'll just do 4. Start batch update. So as you can see, it's running through iteration 1 of 7. It should take about a minute to complete this task. The program is finishing. Now if you recall, I did ask for 6 iterations, but it says 7. The 7th iteration is computing residuals. So we just happen to call that an iteration. And residuals are the shot and receiver remainders from the model. So it ray traces the model, compares the shot and receiver tomo times to the user times, takes an average error or an average difference and calls that a residual. And those residuals can be added to the statics. So over here, we're going to compute statics. Oh, well, actually, let's look at our model first. Here's our profile. Go back over to here, look at our map. And now you can see we have our model. And this represents the node hits. So there was a tendency for the program to cluster along here at about 120 feet deep or so. And then there was another refractor that was finding out here at about 250 feet deep, or an elevation of about -180. So these are pretty much two refractors that it was finding. And so these are our node hits, or node sampling. So it had more hits at red, and then the blue, you can see there's a few places where it had to interpolate. And now here's our model, and the model itself goes all the way up to 3,600. So I started up with 5,000. It found velocities actually at 3,600 up near the surface over here to the left, which is the north-southwest part of my survey. So let's compute some statics. I'm going to compute some statics down to about -150. This is where it looks like we're getting out of the slow velocities and into the faster velocities, about 56, 5800. So I'm going to do -150 here. And I'm going to use a final datum of 100 and a replacement velocity of, say, 5,500. However, I'm going to, and here's my residual corrections, and I recommend you try this computing statics with and without these. So let's call it, let's do it with these at this point, and we'll call them Tomo 3D resid. So I'll have a clue about what I was doing there. And I'm going to force the statics to be zero mean. So if I compute the statics, it just takes a second. Now under, there's several places we can look at this. Under the base map, for example, I can reload the list of columns, and I'm going to plot the Tomo 3D resid. So here's our residual statics. Here's our Tomo statics. And as you can see, they are zero mean. 0 is green here, down at the bottom. They range from about 15 plus to about -10 or so negative. There's other parameters we can look at on here. We can plot DTA, under DTA, or under Tomo residual error. This is the actual values that are going to get, that we could add to our statics. And we have the total error. And so these shots, this shot up here would be a problem shot that we might want to look at the picks on that. And we can look at that under the pick window here also. So under here, under the pick window, we can look under Tomo 3D total error. And here's that red one. And don't see too much of a problem. Maybe a mispick or two, no big deal though. So that's the worst one we have, and we can actually apply the solution here. So under here, I'm going to apply the Tomo solution. Oh, and it's actually a geometry error. So the Tomo actually found the geometry problem, and if I plot this azimuthally, we can see that this is indeed a geometry problem. You can see the classic sinusoidal movement here. So here I can say move to suggested location, and now that's been corrected. So the tomography can be applied to our data, and we can also use it to find geometry problems, just like we do with our normal delay time analysis. So and now we have a set of statics that we can apply and export to our processing system. Thank you very much.